Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum. My name is Imran Amjad from Hamza Army Public School and College, Rawalpindi. Chapter number 4, Turning Effect of Forces. This is the last lecture of this chapter. Today our topic is equilibrium. First condition for equilibrium, second condition for equilibrium, states of equilibrium. First, what is equilibrium? A body is said to be in equilibrium if no net force acts on it. It means if a body has zero acceleration, then it is said to be equilibrium. As shown in figure, there are two stones 50 and 50 on the left hand side. On the right palm there is 100-gram stone. So both are equal, depend upon the masses, so the lever is in equilibrium state. The next is Newton's first law of motion tells us that a body continues in state of rest or of uniform motion in a straight line if no resultant or net force acts on it. For example, a book lying on a table, or a picture hanging on a wall, or at rest. The weight of the book acting downward is balanced by the upward reaction of the table. Consider a log of wood of weight W supported by ropes as shown in figure. Here the weight W is balanced by the forces F1 and F2 pulling the log upward. In case of object moving with uniform velocity, the resultant force acting on them is zero. A car moving with uniform velocity on a leveled road and an aeroplane flying in the air with uniform velocity are the examples of bodies in equilibrium. This is the example. The two forces F1 and F2 pulling the log in upward direction, and the weight of this log is acting in downward direction. These forces acting the log are upward forces F1 and F2 and the weight W in the downward direction. So this is in equilibrium state. A cyclist pushes the pedal of a bicycle. This forms a couple that acts on the pedals. The pedal causes the tooth-head wheel to turn, making the rear wheel of the bicycle to rotate. There are few questions about equilibrium. What is meant by equilibrium in physics? When all the forces that acts upon an object are balanced, then the object is said to be in state of equilibrium. If an object is at equilibrium, then the forces are balanced. Balanced is the key word that is used to describe equilibrium situation. Thus, the net force is zero and acceleration is 0 meter per second square. The next is, what is the principle of equilibrium? A few common principles equilibrium are: two-force principle state that if two forces are in equilibrium, they must be equal, opposite and collinear. Three forces principle that if the three forces are in equilibrium, then resultant of any two forces must be equal, opposite and collinear with the third force. This is the best example of triangle. If the vector are added, head to tail rule. If two vector A and B are added, the resultant R is equal to A plus B is the third vector or third force. What is equilibrium in simple words? Equilibrium is defined as a state of balance or a stable situation where opposing forces cancel each other out and where no changes are occurring. An example of equilibrium is in economics when supply and demands are equal. An example of equilibrium is when you are calm and steady. What are the conditions of equilibrium? An object is in equilibrium if the resultant forces acting on the object is zero, or the sum of the moment acting on an object must be zero. There are two types of conditions of equilibrium. First is first condition and the second is second condition. First condition, sum of all the forces acting on a body is zero, and the second is sum of all the torque acting on the body is zero. Can a moving body be in equilibrium? A body is said to be in equilibrium if the net force acting on the body is zero by Newton's second law, the acceleration of such object be zero. Dynamic equilibrium, when the net force acting on an object is zero and if the object is moving at a constant non-zero velocity, then it is called dynamic equilibrium. There are two types, static and dynamic. Static means a body is at rest. This is static equilibrium. In dynamic equilibrium, body is moving with a constant velocity. If the body have constant velocity, then its acceleration is zero. If the acceleration is zero, then the net force is also zero. This is called dynamic equilibrium. Conditions for equilibrium. In the above examples, we see that a body at rest or in uniform motion is in equilibrium if the resultant force acting on it is zero. For a body in equilibrium, it must satisfy certain conditions. There are two conditions for a body to be in equilibrium. First condition for equilibrium. A body is said to satisfy the first condition for equilibrium if the resultant of all the forces acting on it is zero. Let n number of forces F1, F2, F3 up to so on Fn are acting on a body such that first condition for equilibrium, a body is in translational equilibrium if and only if the vector sum of the forces acting upon it is zero. Sigma fx is equal to 0, the forces along x-axis, and sigma fy is equal to 0, the forces acting along y-axis. Consider a picture is hung on a wall. The tension of the rope is equal to the weight of the picture, so both the forces acting on the body in equal in magnitude but opposite in direction, so the picture on the wall is in equilibrium state. The symbol sigma, sigma is a Greek letter. This is a sigma symbol. This is called summation. Summation means sum of all forces, etc. The symbol, this is a Greek letter called sigma used for summation. Equation is called the first condition for equilibrium. So if a body have many forces apply, F1, F2, F3 up to so on Fn is equal to 0, or sigma fx is equal to 0. The first condition for equilibrium can also be stated in terms of x and y components of the forces acting on the body as F1x, F2x, F3x up to so on Fnx is equal to 0. So similarly in y direction F1y plus F2y plus F3y up to so on Fny equal to 0. So sigma Fx is equal to 0 along x-axis and sigma Fy is equal to 0 along y-axis. This is the example. A paratrooper coming down with terminal velocity is in equilibrium. Terminal velocity is a velocity. The upthrust force or a tension along the string of paratrooper is equal to the weight of a person. The person at a velocity, this is called terminal velocity or constant velocity. So this is the best example of equilibrium, first condition of equilibrium. The next is second condition for equilibrium. First condition for equilibrium does not ensure that a body is in equilibrium. This is clear for the example. Consider a body pulled by the forces F1 and F2 as shown in figure. The two forces are equal but opposite to each other. Both are acting along the same line. Hence, their resultant will be 0. According to the first condition, the body will be in equilibrium. Now, shift the location of the forces as shown in figure. In this situation, the body is not in equilibrium, although the first condition for equilibrium is still satisfied. It is because the body has the tendency to rotate. The situation demands another condition for equilibrium in addition to the first condition for equilibrium. This is called second condition for equilibrium. According to this, a body satisfies second condition for equilibrium when the resultant torque acting on it is 0. Mathematically, sigma tau equal to 0. What is second condition of equilibrium? The second condition necessary to achieve equilibrium involves avoiding accelerated rotation, maintaining a constant angular velocity. A rotating body or system can be in equilibrium if its rate of rotation is constant and remains unchanged by the forces acting on it. Can a body be in equilibrium if only one force acts on it? No. Single force cannot hold equilibrium. Equilibrium requires forces to be balanced. So it requires at least two forces, minimum two forces, unless there are zero force acting. The question arises, why do we need equilibrium? Since the forward and reverse rates are equal, the concentration of the reactant and product are constant equilibrium. This is the chemistry terminology. Okay, when a reaction proceeds, reactant can react into product. A stage comes when the reactant goes to product and product reverse back into the reactant. This position is called equilibrium. The equilibrium constant can help us understand whether the reaction tends to have a higher concentration of product or reactant at equilibrium. This equilibrium shows in chemistry book, chemical equilibrium. This is very important. This equilibrium tells you how reactant is used, how product is formed, whatsoever. What is equilibrium and why is it important? Equilibrium is the state in which market supply and demands balance each other, and as a result, prices become stable. Generally, an oversupply of goods or services causes prices to go down. which result in higher demands. The balancing effect of supply and demand result in a state of equilibrium. Why is static equilibrium important? Static means rest. An object in translational equilibrium is not traveling from one place to another, and an object in rotational equilibrium is not rotating around an axis. Static equilibrium is a valuable analysis tool. For example, if two forces are acting on an object that is in static equilibrium, that means they add up to zero. Is there any body which is at rest but not in equilibrium? If a body is in at rest, resultant force is zero. If a body is moving with uniform velocity, still the resultant force is zero. These bodies will be in equilibrium. Similarly, a rotating ceiling fan is in equilibrium as net torque acting on it is zero. This is assignment for you, my dear student. Quick quiz. There are 4 questions. A ladder leaning at a wall as shown in figure is in equilibrium. The weight of the ladder in figure produce an anti-clockwise torque. The wall pushes the ladder as a stop. This quick quiz mentioned in your textbook. You have seen and write down the assignment and sending me on my WhatsApp number. States of equilibrium. There are conditions of equilibrium. There are two, first condition and second condition. Now our topic is states of equilibrium. There are 3 states of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium. A body may be in one of these states of equilibrium. Number first, stable. A body is said to be in stable equilibrium if after a slight tilt it returns to its previous position. This is called stable equilibrium. If you have disturbed a body, the body regain its position. This is called stable equilibrium. For example, a book is lying on a table. The book returned to its previous position when let free after a slightly tilt. Consider a book lying on the table. Tilt the book slightly about its one edge by lifting it from the opposite side as shown in figure. It returns to its previous position when set free. Such a state of the body is called stable equilibrium. When a body is in stable equilibrium, its center of gravity is at lowest position. This is very important. If the body have its center of gravity is at lowest position, this is stable. When it is tilted, its center of gravity rises. It returns to its stable state by lowering its center of gravity. A body remains in stable equilibrium as long as the center of gravity acts through the base of the body. Consider a block as shown in figure. When the block is tilted, its center of gravity G rises. If the vertical lines through the G passes through its base in the tilt position as shown in figure, the block returns to its previous position. If the vertical line through G gets out of its base as shown in figure, the block does not return to its previous position. It topples over its base and moves to a new position. It's called stable equilibrium. The question why a vehicle is made heavy at its bottom to keep its center of gravity as possible as low. A lower of center of gravity keep it stable. Moreover, the base of the vehicle is made wide so that the vertical line passes through its center of gravity should not get out of its base during a turn. Unstable. If a body does not return to its previous position when set free after a slight tilt, it is said to be in unstable equilibrium. Take a pencil and try to it in the vertical position on its tip as shown in figure. When you leave it, the pencil topples over about its tip and fall down. This is called the unstable equilibrium. In unstable equilibrium, a body may be made to stay only for a moment. Thus, the body is unable to keep itself in the state of unstable equilibrium. The center of gravity of the body is it at highest position in the state of unstable equilibrium. As the body topples over about its base tip, its center of gravity moves toward its lower position and does not return to its previous position. Vehicles are made heavy at the bottom. The lower their center of gravity and helps to increase their stability. The last state of equilibrium is neutral. If a body remains in its new position when disturbed from its previous position, it is said to be in state of neutral equilibrium. Take a ball and place it on a horizontal surface as shown in figure. Roll the ball over the surface and leave it after displacing by its previous position. It remains in its new position and does not return to its previous position. This is called neutral equilibrium. In neutral equilibrium, all the new states in which a body moved are the stable state and the body remain in its new position. In neutral equilibrium, the center of gravity of the body remain at the same height irrespective to its new position. There are various objects which have neutral equilibrium, such as a ball, a sphere, a roller, a pencil lying horizontally, an egg lying horizontally on a flat surface, etc. Stability and position of center of mass. As we have learned, the position of center of mass of an object plays an important role in their stability. To make them stable, their center of mass must be kept as low as possible. It is due to this reason racing cars are made heavy at the bottom and the height is kept to be minimum. Circus artists such as tightrope walkers use long poles to lower their center of mass. In this way, they are prevented from topple away. Here are the few examples. A needle is made to the center of mass, make the object stable. These objects return to their stable state when disturbed. In each case, center of mass is vertically below their point of support. This makes their equilibrium stable. Show a swing needle fixed in a cork. The cork is balanced on the tip of the needle by hanging fork. The fork lowers the center of mass of the system. The last, show a preached parrot which is made heavy at its tail, shown in figure. Toy that keeps itself upright. When tilted, it has a heavy semi-spherical base. When it is tilted, its center of gravity rises. It returns to its upright position at which its center of mass is at the lowest. Okay, my dear student, I am giving to your assignments. There are a few questions as shown in figure. What is meant by equilibrium in physics? What is principle of equilibrium? What is equilibrium? Simple words. What are the conditions of equilibrium? Can a moving body be in equilibrium? What is second condition of equilibrium? Can a body be in equilibrium if only one force acts on it? Why do we need equilibrium? Okay, my dear student, hope you will be enjoy and understand my lecture. If you have any query, any problem, ask to the subject teacher. Thank you. Allah Hafiz.